these people. So now, according to our program, we start our session, which is devoted to case histories. And according to the program, the first speaker of this afternoon session devoted to case history is Andrea Caregari, who is the head of operation and maintenance of E-Distribuzione. Contrary to what has been done concerning the keynote speaker, I will ask the speaker now, the panelists, to briefly introduce themselves. The title of his speech will be Flexibility Services, Content, Context, and Enabling Technologies and Case Histories. So Andrea Caregari, the floor is yours.
Thank you, Professor Lucci, and good evening, everyone. I'm Andrea Caregari, head of the Operation and Maintenance Department at E-Distribuzione, and I want to thank you all for inviting me and for the opportunity of speaking in this conference. So, what will be the role of DSOs in this changing scenario? A system operator and an enabler of the energetic transition. The old energy system model in which the DSO had a passive role is outdated. DSOs basically had to guarantee grid operation, ensuring hosting capacity and quality of service, the so-called fit and forget model. But the current scenario is different. The distributed generation is diffused in the distribution network, and it is unpredictable. Moreover, the ER generators are often far away from the power consumption areas. So the DSO has to change towards a new role to manage this new complexity. He has to observe and control the distributed production to optimize energy flows and grid operation. Moreover, the DSO has to act as a catalyzer, interacting with many stakeholders. In this context, DSOs will be the neutral facilitator in defining market models and coordination schemes to exploit new flexibility solutions aimed at supporting congestion management, outage prevention, or voltage control. Following the resolution 352 by the Italian energy regulator, E-Distribuzione is going to present a pilot project that will allow to evaluate all the phases of the flexibility service procurement in real operative condition for the optimal management of distribution network. Services will be procured through public competitive tenders in order to get bilateral contract on specific flexibility products. The experimentation purpose is also addressed to define communication standards for a secure exchange of data between DSOs and flexibility providers, as well as between the DSO and the TSO, and to better investigate costs connected to the development of technologies and platforms in order to support the definition of mechanisms to remunerate DSOs. In this chart, we will start our path through the distribution system of the future. The first step is for sure the set of the flexibility service the DSO will make use of in order to face the emerging challenges. The flexibility concept, in fact, can offer a solution to some of DSO needs, such as voltage and power control. DSO will provide production and consumption plans for a target period, and they will be reorganized in order to comply with network constraints and optimization. Flexibility service will play a key role in order to reduce the impact of this reorganization. DSO can also activate a set of flexibility service to guarantee a backup in case of unexpected events such as faults or network reconfiguration. Another relevant application of the power control is represented by the load shedding service. During the operation of the network, the DSO must face the challenge of the load management. In particular spot situations, it would be very useful to reduce the amount of power flowing through network. A typical example is represented by the exigency to reduce the load in case of fault or maintenance works. Finally, DSO could manage the reactive power flows within its networks and comply with the TSO reactive exchange requirements. For this purpose, E-Distribuzione is working to set up and run 3 pilot projects that will last 3 years in 3 Italian areas: Foggia, Benevento, and Cuneo. These areas have been chosen because of the distributed generation, and at the same time, the operation is already integrated with a large number of sensors and communication technologies. Moreover, according to the estimation and simulation, in these areas, the voltage control to low to LV customers can become critical and can require a dock solution in order to ensure the compliance with the technical standards. Well, we will go deeper into the first of the 3 mentioned projects, Foggia. As you may know, we have just identified the entire Puglia region as relevant for smart grid projects. Here, the network is equipped with the technologies of the Puglia Active Network that allow best observability of medium voltage network parameters, integration with power plant controller, centralized and advanced voltage regulation, network automation through the smartphone selection scheme. The selection of the pilot site requires to be characterized with numerical indicators designed to quantify and compare each other the candidate sites. A first measure used for the selection of primary substation is represented by the active power transits, measured at the interface with the high voltage network, and an indicator of the behavior is represented by the percentage of annual hours in a reverse flow condition. The power inversion was evaluated for each single MV line. Furthermore, the power profiles, active and reactive, together with the amplitude of the currents, were also used to estimate the degree of use of the conductors in normal operation, but also and above all when the line is used as a backup feeder, so as to highlight possible limitations on the ability to reconfigure the network after failures. The voltage profiles were also collected and processed, in particular to identify violation of the voltage profiles exceeding the limit of the voltage nominal value measured at MV bus bars, disturbances in primary substations such as slow rapid voltage variation, voltage dips, and so on load tap changes switching frequency in order to assess how often is required voltage regulation. In addition to the above indicators, the selection was also driven by analyzing supply continuity indexes and congestion on the lines. On top right of the chart, we see the dispersed generation values installed in the various provinces of Puglia. These values are compared with the request for connection to the grid operated by E-Distribuzione and with the power flows recorded on the grid at the minimum load condition. By including connection requests or new DG units that could potentially connect, Foggia emerges as potentially critical. In this regard, the figure on the bottom right of the page shows the active power detected through MV lines of a substation. In a typical summer week, it's possible to observe how most of the line shows a remarkable active behavior. From these considerations and analysis, Foggia seems to be the most suitable area for the pilot project. Well, in this chart, we will talk about the procurement process of the flexibility services. National Grid's Future Energy Scenarios 2018 studies show that models in which the DSO plays the central role of facilitator and user produce the greatest net benefits for the electricity system. For these reasons, following the indications provided by regulator documents, the chosen procurement model identifies the central role of the DSO in the procurement of ancillary services for the management of its networks. Customers will therefore be divided into 2 categories for the purpose of providing flexibility. MV customers already included in the Puglia project, who will be able to provide services directly once the power plant controller is installed. MV and LV customers who are not included in the first category or who do not wish will be able to provide services only through an aggregator. In the first case, the flexibility products will be activated by E-Distribuzione, directly using the functions provided by the central plant controller, and it will be possible for the MV customers to communicate and directly implement requests for flexibility by the DSO. And as you can see, nowadays, more than 1,000 MV customers are connected to the grid, and almost 500 prosumers are potentially ready to take part of the flexibility. Going further, the procurement process consists of the following main stages: review of the network development plan, flexibility need identification, and at the end, competitive procedure. Let's jump now to the technological side of the flexibility. On the top, you can see the advanced functionalities already online on the Puglia network. The advanced voltage regulation system that applies optimization algorithms through the ADMS, using data collected from our new smart grid devices such as the RGDM and the open meter. The calculated optimal set point is then set by the new DV7500. The smart fault selection algorithm that will enable us to perform fault selection in less than 1 second and to significantly improve quality of service. Finally, communication. Data will be exchanged between network nodes to ensure efficient operation of our network. To give a clear example, in the scheme, there are some of the new technologies E-Distribuzione developed with the Puglia project to improve grid observability and flexibility. Regarding the primary substation, here we have the TPT 2020 that implements a local intelligence for a precise event diagnosis together with local automation functions. And then the new protection panels, DV7500 and DV7203. The first one enables the advanced voltage regulation. Regarding the secondary substation, we have the new UP 2020. It implements functions similar to the TPT 2020. The RGDM, the Advanced Fault and Measure Detector, that implements many functions related to fault location, measurements, and power quality. And the Smart Termination, a voltage and current high-precision sensor easily installable on existing cables. And
3 more minutes.
And finally, we are going to investigate flexibility benefits and how we expect to recognize these benefits in the pilot projects we are dealing with. As you can see on the left side, the future distribution networks will enjoy some benefits coming from the large use of flexibility services in the daily operation. The network development related benefits in terms of investment reduction and resilience of the networks are both economical, and they involve medium and low voltage networks. From a system stability point of view, flexibility can enhance the strength of the balance between load and generation. For what may concern the network operation issues, losses can be reduced through an optimization of the power flow across the network. Then, medium and low voltage regulation is one of the most important benefits. Large amounts of dispersed generation, in fact, causes relevant issues, especially for traditional networks where it is run only at substation level. DSO will be able to shape voltage profiles, and this shape will become reality thanks to reactive injection or absorption carried out by prosumers. Moving to the right side of the chart, you can see a brief list of how the mentioned benefits will be declined and found in the results of the pilot project in Foggia. For the evaluation of the experimentation results, technical economic indicators are like those employed for the choice of the pilot site. The exploitation of flexibility strongly depends on the response of prosumers connected to the lower voltage levels in the electricity chain, subjects who are not used to supply products, services to the system. The definition of the indicators relating to this response can be detailed only after the procedures for procuring flexibility and after the definition of the remuneration procedures. It will be possible to evaluate numbers of activation carried out with respect to those requested, number of schedule activation with respect to the agreements, correspondence of the profile of the flexibility supply with respect to the request. The evaluation of the potential impact of smart grid is strongly linked to the ability of the grid itself to improve the integration of dispersed generation, especially from non-programmable renewable sources. For the mentioned purposes, the project takes as a reference the technical indicators designed to quantify the hosting capacity of the network. Finally, something about scalability. The scientific literature applied to the development of European projects on smart grids agrees in identifying technological development, interfaces, and modularity of software platforms as driver of scalability. Following the same approach, the project will be subjected to scalability and replicability analysis, considering both the scope of E-Distribuzione networks and the broader national scenario. And that's all. Thank you for your attention.
Thank you so much, Engineer Caregari. This was an extremely interesting presentation. And I do not see questions in the relevant box, but I might have a couple of questions for you. And the first one is the following. What's your opinion? I mean, if some flexibility services were available nowadays, what would be for you the most useful application? And a second relevant question, which is, which additional flexibility services could be used for the TSO in the mid-long-term future? I may add also a third one, but please try to be very short in your answers.
Okay.
What about the role that in all this can energy communities play?
Now, first of all, in addition to the mentioned need for the voltage regulation to low voltage customer, some load shedding application would be useful in case of fault management, in order, for example, to reduce the risk of double faults on the counter-feeding MV lines. We suffer from this, especially in the summer. And then the direction we are working to is the increase of the customer centricity. The chance given by distributed smart device must be exploited as more as possible, allowing a growing participation of the customers in voltage, power, frequency, and so on regulation. So I think it's important the centricity of the customer, and at the end, the centricity of the DSO, the distribution systems operators. Thank you, Professor Nucci.
Thanks to you. Indeed, this is very much what is being wanted by the European Union, and it's very clear from all the movement around. Thank you again very much.
Thank you.
Now we need to switch to the second speaker, who is Giorgio Maria.